Hi and welcome to the Groove Monkee video series on processing drums. This first chapter is going to have a look at EQ, and we're going to start at the beginning, first of all looking at what EQ is and why we need it. So we're going to look at some of the basics of audio engineering and what sound actually is. Then we're going to move on to the EQ devices themselves and look at some of the characteristics of them. Then we'll have a look at some techniques for EQing drums. So to start with, just to briefly describe what sound is basically a series of vibrations in the air that the eardrum can detect. And the pitch of sound is determined by the speed of those vibrations. So, for example, a low guitar string vibrates much more slowly than a high guitar string. So there's a direct relationship between pitch and frequency, which is the term we use to describe these vibrations. Now, frequency is measured in hertz, which is the number of vibrations per second. So 1 hertz would be 1 vibration per second. Now, we can't really hear a vibration that slow. Generally speaking, the human ear can hear roughly between 20 hertz or 20 vibrations per second up to 20,000 hertz, or what they call kilohertz. Any amount of 1,000 hertz is referred to as 1 kilohertz. Now, the other way that pitch is measured, according to musicians, is in semitones, or musical notes in other words. Now, they directly correspond, and we'll see in a moment, using this spectral analyzer that's available in Ableton Live. You can get spectral analyzers for free off the internet, or you can buy some that are maybe a better quality. A lot of DAWs have their own spectral analyzers. I highly recommend using one when you're learning about these kind of topics. It really gives you a good picture of what's actually going on under the surface. So to start with, we're just going to play a sine wave, which is basically the purest type of waveform you can get. It's more or less a pure vibration that you won't really find in the real world, insofar as there isn't really any sound that's that pure. You might find instruments like flutes sounding close to that pure, but they still have extra sounds that give them their own unique character. Now, first of all, let's just have a look at this sine wave. And when we have a look at it on this spectral analyzer, you can see there's this one peak here. It's represented on here by this peak that shows us, if you have a look down in the bottom left here, it shows us the frequency in hertz, so Hz is the abbreviation for hertz, and it also tells us underneath the musical note. So that's a C3 note, and it's 261 hertz. Now if we move on and have a look at a piano, you can see it's playing the same note, which is a C3, and we've still got a peak here at 261 hertz or C3, but we've also got all these other peaks as well. Now these are actually called harmonics or partials. Partials is basically probably the more accurate name for harmonics, because harmonic generally implies that it has a harmonic relationship to this first peak. Now this first peak is actually called the fundamental frequency, and that is what decides what actual musical note is playing. Let me just stop that while I'm talking. The fundamental frequency is that actual C3 note, and all of the rest of these peaks are basically what give the sound its own unique character or timbre. So that's why the piano has so many more peaks, whereas a sine wave has very little character. It's literally just like a beep. No extra character, is a very dull sound, and that's because it has no harmonics. Now the reason I said that maybe the more accurate name for harmonics is partials is because, as we're going to see later on, when we're looking at drum sounds don't tend to have that melodic relationship that instruments such as pianos and guitars have, because they're not intended to play melodies. They're percussion sounds. So the harmonics won't necessarily have that harmonic relationship. In other words, they won't adhere to the harmonic series. So what they are often called is inharmonic partials. So really, partials is just more of a catch-all term that allows you to refer to inharmonic and harmonic partials at the same time. So I'll probably use the term partials more often than I say harmonics. So moving on to EQ and how this is significant in this situation. EQ is basically like Now if I just drag one in, it's basically like a type of volume control for different frequencies. So this particular EQ that comes with Ableton is an 8 filter EQ, so you can have up to 8 of them going at once. We're only going to use one to start with. Now, basically it allows us to pick a particular frequency band, so you can see here the frequency, and we can turn that band up or down. And that allows us to have direct control over the actual character of the sound. So if you can see, in the case of this piano, you can actually kind of see it going on here. And what we're actually doing, I might try a different filter, is we're reducing the volume of a lot of these harmonics. That's having a direct effect over the sound. And if I maybe boost it around here where that peak is, you might notice it's starting to actually sound a lot more just like the original sine wave. So we're taking away a lot of that character by turning these extra harmonics down. So EQ allows us to affect the character of the sound, so we can use it creatively to make a sound nicer, but we can also use it correctively to take away elements of a sound that we might not want in the mix. You can use it in a very kind of functional way, such as to get rid of hum, or we can also use an EQ to mix sounds together. So what you'll find is when you mix more than one sound together, then certain frequency bands will become stronger because both sounds might have a lot of energy in the same frequencies. And we'll especially find that once we start looking at mixing kick drums together, especially if you're going to mix a kick with a bass guitar, which probably in most cases when you're making music you will be, or at least some kind of bass instrument. So it's really important to look at what's going on in the frequency spectrum with each sound, and we can then decide whether we need to cut or boost certain frequencies in order to make sounds fit better together. So really mixing sounds together is probably the most important use for EQ that we're going to look at in this series. But of course there's a third use for EQ, and that is just as an effect. You can maybe create sort of telephone effects by filtering out a lot of frequencies, make it sound like it's playing over a phone. And also by automating it, you can sweep through the frequencies. So EQ is really probably one of the most useful and important devices that you'll use in any kind of music production, or even in any type of audio engineering.